I've run into a couple of problems recently. So one of these problems is that I want to do more reading. I thought, okay, maybe what I can do is while I'm walking to and from work, I can listen to an audiobook. Unfortunately, the kind of books that I'm reading are pretty technical. They're like historical works or philosophical works. So it's very difficult to find an audiobook about them. The second problem I faced recently is that I'm in a lot of meetings, and sometimes it's quite taxing to be taking notes for those meetings. I went in and I actually built some software tools to do conversion of audiobooks and to take some meeting notes and summarize them, or even just take a recording of a meeting and summarize that into notes. So I thought, okay, that is just one step away from building an AI voice assistant. At its most basic, this voice assistant should be able to detect some voice, take that detected voice either through a button press or just like a vocal recognition, convert that into text, take that text and feed it into some kind of large language model. And the large language model should be able to respond, maybe it's cloud connected, and respond, produce its own text, and then take that text and output an audio voice. So how do we actually do that in practice? So before I really get started, what I want to do is just show you a demonstration of what this software really looks like, so you have some inspiration. So looking at the screen, you can see that I have all this code written up. Code is written up in something called a Jupyter Notebook, which is a nice way to debug some code, right? So you can write the code step by step and immediately run it and execute the different steps. So first thing I'm going to do is I'm going to load up the variables by running each of the code segments, and then I will start the process off. I'm going to run the final bit of code. What is the capital of Canada?
The capital of Canada is Ottawa.
How many countries are in the world?
There are 195 countries in the world.
Who is the tallest person in the world?
The tallest person in the world currently is Sultan Kosen from Turkey, who stands at 8 feet 2.8 inches tall.
Thank you for your help.
You're welcome. If you have any other questions, feel free to ask.
Okay, there you go. So what we can do now is exit. Since it's still recording, I will just go up and stop the program from running. To do this, we're going to use a few different tools. I'm going to stick primarily to Python as a tool, Python as a programming language, and I'm going to assume that most of you who are listening have some knowledge of Python. And second, I'm going to use a tool to program the Python, which is called Visual Studio Code. I will use, along with it, package managers called pip and conda. We need to find a way to break this problem down into smaller segments or chunks. For us, we're going to start with the process of extracting data, audio data, from our computer microphone and passing it over into an audio file and a text file. So what we're doing here is we're taking each of the three macro steps, and rather than like taking variables themselves to pass information from one step to another, we have a permanent memory storage. So we store it into a file, the data. So let's say I record the audio, convert that into text. So I store the text into a file, I store the audio into the file, and then I can pull out the information directly from the file to do the next step. In this way, we have kind of shared memory, but it's not memory, it's a permanent disk storage. So in that run that I just did, you can see that there is a whole bunch of files that have been created. I have one file that's a application.ipynb, which is the Jupyter Notebook. That's where all the code is sitting. And I have a whole bunch of other files like the output text. So if you look at that, so here's the response from the LLM. And this is my question to the LLM. And then we have an output audio file. So
thank you for your help.
That's me talking. And then we have another one, which is the response.
You're welcome. If you have any other questions, feel free to ask.
So we have some files stored information in our shared disk memory. Let's create a new file and I'm going to take you through step by step the process of how I coded that file. I'm going to run through this at a pretty rapid pace, so you may not be able to really follow along to the same extent that I would normally say you should. But hopefully it'll give you an idea and some inspiration to get started with your own coding, and then we can delve into it if you have any questions later. First thing is we'll go in and create a new file. Let's do that. New file. I'm going to create a Jupyter notebook, and let's just save that notebook file, save as, and we'll just give it a new name, new application, and save. So you can write a snippet of code. For example, you can choose Python code. You can select a kernel, and the kernel is, I've pre-created it for us. It'll be a Conda environment, and that Conda environment will install a version of Python, and that version of Python is what you're going to select. That's our interpreter. So I can go in now and I can do a print statement just to show you, demonstrate that it's all working. Thanks. Okay. And then to run it, I just hold down Shift and Enter, and it runs the code and it shows the output displayed. Let me just bring up a markup section of the code, which is basically, or markdown I should say, which is basically each section which has HTML in it, and you can take that HTML, render it into something a little bit more beautiful for documentation. First thing we want to do is listen, and what we want to do is listen for a threshold of audio. So when I speak, if I'm speaking loud enough and close enough to the microphone, I want to detect when that happens, and that's my cue to start recording audio for the LLM. So that's my first step. After the listening is done, I've got the threshold detected, then I can go in and record, right? So that's step 2. Oops, let me just put this into a list. Yes, right there. There we go, we've got a list. Once we've done the listening and the recording, we're now ready to extract the text from the recording. So we're going to go ahead and extract the text. And once the text is extracted, we're going to feed it into the LLM. Then finally, after sending, we should receive some kind of response, right? So maybe we'll have something like this. And then once we received a response, we want to take that response and convert it into audio. And that's responding to the user, right? So these are the main steps that we want to accomplish with this AI voice assistant. We can actually create separate functions for each of these steps and deal with each step independently. So we create a function called listen, right? I'm going to create another one, record. Okay, so we've got our 6 functions that are going to be the core of our LLM, our AI voice assistant. We need one more that's just going to bind them all together and run them. And this function, we will call it main. Copy that over. So there you go. Print hello and run. And there you go. It calls the main function and runs hello. So before we proceed any further, we need a few libraries from our package manager. I've already installed these libraries, but if you wanted to install them yourself, you would go to the terminal window, go to your environment. I'll give you an example of this right here. So first thing is I've created an environment called course. So I would activate that environment. I can see what packages are installed. I can do list, and let me just expand this window. And you see that there's a whole bunch of libraries installed, and these libraries I can then go ahead and use as I want. So these are the libraries I'm going to use. I use PyAudio to grab some of the audio, and then some features are not available in PyAudio, so I need to use another library that's also for audio that is implemented a little bit differently. There's 3 main audio libraries here, and then a 4th one for storing WAV files and working with WAV files. I've got a speech recognition library from Google. I've got another library from OpenAI. OpenAI is very famous now. They have a software called cloud software called ChatGPT, and that ChatGPT's LLM is what I'm using to do the bulk of the heavy lifting of the AI voice assistant. So another useful library is one that converts text back to speech. I'll be using this for the voice synthesis. When you look at these libraries, you see that you've got PyDub, PyGame, Pi audio in there. In my listen function, I've just added a threshold. So when the mic records, there will be a voice level it's looking for before it starts to actually record. And so this is for that. So we're going to have to play around with this depending on our environment and how loudly or softly we like to talk. I'm just going to go in and start by copying this code. I don't want to spend too much time on this right now. And let's just copy the code that we had for our listening. So let me delete that. So I have a comment here. This is a docstring comment. We'll get into that at some other time. And what I do is, as a first step, I want to create Pi audio object. This just initializes an input stream for audio. So we have to open that audio stream first. So what we do is we will go in and open that audio stream. When we're recording audio from a microphone, there's many different parameters. I could listen to the audio in stereo, so I could have 2 channels here, or I could listen to it in mono, that'd be 1 channel. I could have a rate, audio rate, so like 44 kilohertz rate, or I could have a lower rate, so I save some memory storage space on a disk. I've created a dictionary that contains all of this information, right? So if you look at this param here, there's a dictionary here. Once the stream is open, we need to figure out the volume at which we listen and detect a real audio voice. If the volume is below the threshold, we're just going to discard that audio signal. The moment it exceeds the threshold, then we know that someone is speaking at a certain volume. And that's when we want to exit and do something. There'll be a bunch of code over here. I'll pull in some of this code, and you see what we're doing here. I'm just going to bring this down for a moment. We grab the raw audio bytes, we read them from the microphone, we store them, and then we'll take that. These 3 steps, I don't want to focus too much on them. They're a bit technical. These 4 steps, what we're doing is we're unpacking that audio stream, extracting the actual audio sample. This audio variable, what it does is it has an array of samples, right? So 1024 samples, for instance, or 2048 samples. And we're going to take each of the samples, check the entire array, and see which is the sample with the maximum volume, right? And we will say that that is our representation of volume for that chunk of data, audio data. And if that representation exceeds the threshold, we're going to exit this while loop and stop the stream. In the main function, I will call listen using the default threshold of 5,000. After listening, right, it should continue to listen until there's a volume detected. So now when we run this, as long as I don't speak, it should keep running and it shouldn't print anything. But when I speak, it should print this and exit. Let's try it. Test. And there you go. Once we've listened, we can start to record. So I'm just going to copy over the function just to save some time. Again, we need to open up a new stream. In the listen function, we didn't need to record anything. We just listened. If we heard something, then we moved on. Here, we'll do the same thing. We'll open up a stream the same way we did with the listen function. This time, we will record some frames, right? So we have a little storage variable that records the frames. Our volume will vary over time. We're going to assume that we have another threshold, but this threshold will be lower because we want to keep recording. If someone goes quiet for a moment, we want to give them a bit of a chance. So we'll lower the threshold at which we're detecting speech. As long as the volume exceeds that threshold, we want to keep on recording. But when the volume is sufficiently low, consistently low, then we know we've stopped speaking, and that's when we know how to stop recording. This thing tells us how many frames do we really need to record. The number of frames then becomes our length for this variable. There's a time variable. We want to make sure we record 1 second of time of audio. And this array stores the different volume levels for each of the frames that we're recording. We're going to iterate through all the frames we've recorded until we've gone through that many chunks. That represents 1 second of time of audio. And every time we record, we append it to the frame, the number of frames, so the list of frames that we have stored right now, which is 0 in the beginning. And so we keep adding on to the length of that list until we reach the the minimum number of frames that we need to record for that time period. And then we're going to go in and extract the audio volume. We will go in and append it to an array of volumes. If we have like 20 frames of audio, then what we'll do is we'll have 20 list elements of volumes, so 20 volume levels. We will take that list and find the loudest volume. We'll keep doing that until that volume level doesn't meet this condition. That is, the volume is below the threshold value. That's our stopping condition, right? Once we stopped, we'll close the stream and we'll save that audio data into a file. And our file name here, we can pass in whatever file name here we want. That file is located here, that same variable name. And we're going to store the file using the audio format that we first selected above in this dictionary. You should be able to press enter. That should compile fine. You see this check mark is compiled okay. So let's get rid of these files here. Take our new application. Here we're going to add record. So once we finished listening, we're ready to record, right? So print finished recording. Python is an interpretive language, right? So what it has is it has a virtual machine. So it's a layer above. It gives us some independence from the type of processor that's being used on the computer. And now we're going to try this out. Testing. I am now recording. So now we can play. Testing. I am now recording. So there we go. Now we get to a stage where we're actually talking about extracting the text for the LLM. Again, we have an audio file that we can input, right? That's the audio file that we just recorded. And we're going to output text from that process and put it into this output.txt file. So here, this is where we use Google's library. This is called the speech recognition library. If you go to the top, you see it right here. And we leverage existing code so that we don't need to write it again. And so our job is to take the audio file that we've just recorded in the previous function. We'll grab the audio from that speech recognition library, and then we will call its transcription process, right? If there's some problem like the audio is silent, there's no speech, this library will throw, it'll have nothing to recognize, it'll have nothing to transcribe and put into this variable. So it'll throw an exception. We need to catch that exception and exit gracefully and do no recording. So once that's done, we'll have some audio data in here that's been transcribed into text, and we're going to take that text and write it to a file. Extract, print. Let's run our main program. You see sometimes the computer just records and exits immediately. What this means is that, like, even though I'm not speaking, maybe our threshold is a bit too low and my computer has a fan in it and it may be triggering the audio to listen too early. So we'll just go in and we will override our threshold, maybe make it 7,000 and try again. Testing, can you please record this audio? And so you see, we've got now text file. Testing, can you please record this audio? Our next step is to send this to the LLM. Data sent. Now this is where it comes in that we need to interface with this cloud software from OpenAI. So I'm already logged in. So I have here a key. So when you first want to try to access OpenAI's API, you normally have to pay for using the API. Here, I'll give you an example of this. I have paid for this API. I've, in fact, put in $10 in there. I should be the only one who can use it. So I create a key, and this key is part of my public-private key system. So normally, the key is completely secret. You should never reveal this key. This is your private key. I've already created this key for this particular example. For now, I will reveal the key to you on video, but what I'll do is I'll delete the key before the video is published, so you will not be able to use this key directly. I'm just going to grab this code for now. Here again, you saw that we had an output.txt file. That's now going to be our input text data, and we will respond with an output_.txt file. So this output underscore.txt will be the response of the large language model from OpenAI. So we read the file first, this output.txt file where we stored our query. And once we've read it, we're going to say, let's limit the number of tokens that we're exchanging with OpenAI's API. This is to reduce the cost, right? So the more tokens you have in response, the more the cost, the per token cost. Give OpenAI some instructions of how to respond, and then this request text that's coming in from my output file, that's going to be appended with the instructions to construct a prompt for the large language model. And this is my secret key. Normally this should not be in this file. It should be stored in a place where no one can access it. OpenAI has been very conveniently provided a library, so we don't need to manually construct HTTP requests or RESTful requests, which would be normal for API communication. They've already done that for us behind this layer of abstraction constructed with this object here. This is a instantiation of that object. We construct a dictionary object as our part of our message, and we will pass that message to OpenAI Cloud with this function. So at this stage, we're ready to test our send function. Let's go ahead and try that right now. So we've got our send function already created here. And what we can do is just clean out these extra files. We can move that to the trash. Okay, so now we're ready to do the testing. Let's try it. And run. How many people on the planet? So we see that there's 3 files that have been created. So we've got the output file. This is my question. And we've got the answer. As of 2021, the global population is estimated to be about 7.9 billion people. We've also got my initial questions audio file. How many people on the planet? It looks like it's working. We can start to write. I've already done this. I've copied over the function for receive. And basically the idea is next to take the text file, the output_.txt file that's been sent by our OpenAI model from the cloud to us, and to convert it into speech. So this is what's called a text-to-speech engine. The one that I'm using is GTTS, which is a Google library. So it, like OpenAI, goes up to the cloud and does the conversion to speech. Here we see that, again, we read the file that we've created from the response from OpenAI, and then we grab an accent. So what I've done is created a dictionary that essentially maps the GTTS engine's version of string representing a particular accent of English and uniformizing it as an ISO standard format for a particular country. We go in and we call the constructor of our class, and in that class we put in the text that we've gotten from OpenAI along with the language that text is in, and the language and accent in which we want the speech to be generated. This is then saved to an output file, but the output file is an MP3. We want to be pretty uniform with our structure, so we convert the MP3 file into a WAV file. Now that this is done, and we can print just a message, so let's give it a try. How many countries in the world? And we see we've got a conversion, and we can see that there's been an MP3 file generated as well. Let's play this.
There are 195 countries in the world.
And we see the text version of that as well. And there's been a conversion to WAV as well. And you can see my original question, how many countries in the world? And you can hear my original question's audio as well. How many countries in the world? We're almost there. Right? So we have one more thing to do. We need to create a function that actually plays back the audio that's been created. So this is pretty simple. So we're just going to copy that over right now. There we go. So in this one, I shot myself in the foot. So when I created the conda environment, I actually created the conda environment for Python 3.11, which is a fairly new version of Python. Typically people work at Python 3.8, 3.9. And the reason people work at that version number, the older version number, is because some of the libraries of Python don't get ported into the newer version of Python as quickly as one would like. So the consequence is that if you use 3.11, then there will be some libraries that will be broken. They won't be available for version 3.11 of Python. In order to combat this problem, I actually ended up using another audio library called PyName. I initialize this thing called the Pygame mixer, and that mixer is loaded with the sound file, which is the wave file, and that wave file is played through the Pygame library. And this script is put into a loop for as long as that sound is playing. So we don't exit the function until the sound is finished playing. Respond, print. So now we should have our complete AI voice assistant. Let's see whether it works. What is the fastest plane on the planet? You see, we've got a little problem here, and this problem has to do with thresholds. So we're in a situation where the threshold of the audio recording after the listening is too low. Overriding threshold, and we're overriding threshold here as well. I think we've got it working. So let's delete the output files so that we can see that some change has been made. And we're ready to go. So here goes. How many people in the world?
As of 2022, the world population is approximately 7.9 billion people.
So we have ourselves a very simple AI voice assistant. So as you can see, with the advent of LLMs and by using these cloud tools, it's fairly easy to put together something that's like an almost functional AI voice assistant. In the future, what I'll try to do is take you through a process of doing this whole thing with a private implementation of an LLM, and perhaps with a private implementation of speech to text and text to speech software as well. Thank you very much, and please do leave a comment.